Oh, very good. Yes, second talk for tonight and the last one from Daniel. Please take it away. Thank you.
Okay. Oh, hello all. This evening I want to talk a bit about Fluent Interfaces. All you need to know to make your own. I'm Daniel Baker. I'm a Dutch person. I live in Stokkerau, 30 minutes away from here. And I'm a software engineer at the charity, and we're building a headless CMS. And that's a bit about me. I come from a Drupal background, so I used to do a lot of Drupal, PHP. And in that time, I also did a bit of JavaScript and liked it more and more. And so I'm doing this now for 5 years or so, JavaScript. So that's a bit about me. I'm a full stack software engineer, and we're working on a headless CMS. We use a graph database instead of a relational database. And our CMS creates websites, basically, PWAs. And these websites are media catalogs, so you can have videos or podcasts or images, recipes, anything goes. One thing that we have on a roadmap is creating federation between these CMSs. And in this context, in building this CMS, I wanted to create a client-side library. And that's where I learned about Fluent Interfaces. I had to rebuild it a couple times, so I have learned some lessons, and I hope to share them with you. So we'll first talk about what are Fluent Interfaces. We'll go through just general use cases. We'll talk a bit about my use case. Then we dive deep and go about what are the components that make this work. And we'll zoom out and talk about the different types of change. And I'll give some considerations. So what are Fluent Interfaces? You might have worked with them, like jQuery is one. And let's go first to a definition. In software engineering, a Fluent interface is an object-oriented API whose design relies extensively on method chaining. Well, that sounds nice, but what does it look like? So you all use this probably, or have in the past. So basically, what makes up the Fluent interface is that you can chain it. So you have this dot, you can do some action, and you can do it again and again, and make a chain. So that's a Fluent interface. Here we have another example, an entity builder. We create the person, and this person holds some state, and we name it John Doe, give a date of birth, and we save it. Here is another example. This is an example of a library that uses a library that I built called Fluent Snake. Fluent Snake helps you create Fluent APIs and especially make them asynchronous. So a Fluent interface has there are different complexities. You have a very simple one, and you can have more complex ones, and asynchronous things in Fluent interfaces are kind of hard sometimes. So what you see happening here is it fetches a Wikipedia URL, and then a query selector grabs something from the page and fetches that, and then grabs another text, and then returns the text. And that all is with one await. So you have one long chain that's executed. Here is something I'm really passionate about. It's a little bit a sidetrack, but this is also a Fluent interface. LDFlex is a system that uses linked data, and I can give an example. So I'll first explain this one. So we see that my website is queried, and then in the source code, there are special attributes, meta, tags, and an image is fetched. And so I hope this is big enough, but what you see here is a bit of how simple can, how easy can a Fluent interface be. Like it hides a lot of complexity, but so now it fetched an image. And so underneath this system, underneath Solid and LD Flex, it's possible to connect to databases or fragments of data or to websites as documents. So there's a lot of complexity there. And for me, it's just one line of code, and that's awesome. So that's a bit what Fluent Interfaces give. It's more a developer tool. So it abstracts on top of complexity. So if you have lots of stuff happening, you can abstract that away, and it can be used very nicely. It feels like objects. You can just type and it works, and you can have TypeScript auto completion. So we go through the use cases that you have. You might have used this one, Moment.js. It's just a simple library. It's great, and it types easily. Here you have another example, D3 for statistics or in infographic things. Here's an example that I want to point out because it abstracts away lots of stuff. So as I told, this RDF stuff can connect multiple sources at once. So you have one query that goes on multiple sources. And one result of that is that instead of one response, you get a stream. And those are hard to deal with. So this is a prototype I made with LD Flex and micro-HTML. And micro-HTML is similar to React. And so what happens at the H1, at the header 1, is personal name is a promise, and it's a Fluent interface. But micro-HTML resolves all promises, so you don't have to deal with the promises. And here the person of friends, the given name is there's a lot of complexity behind because it's basically a stream. And it's a stream that when you pull, it will give more. So you could imagine a load more button, and then it pulls more from the sources that are attached. And so this map function under the hood is a bit different than an array map. But what I wanted to point out is you can very nicely hide complexities. Another example where it's many times used is a query builder, so ORM systems like Knex. So I'll tell a bit about my use case and what I learned and what we wanted to build. So as I said, we're creating a headless CMS, and we have lots of media types. So we have videos, audio, ebooks, and all these things have categories and keywords. And all these things are multilingual. So an ebook can be in multiple languages. And one other use case we have is online and offline. So our front-end apps, they should work. Like, for example, Spotify, you want to listen to an audio, to a CD when you're somewhere else and don't have internet. So you download it to your phone. And that also is with our PWAs. So we wanted to support offline and online usage. And so we wanted easy integration, but we also... So we wanted easy integration, but on one hand, we wanted to control some features, and we wanted to be able to add new features. So a library was born. And this is just a small example of how you use our CMS. And so this ebook.title that you see there is basically a promise. And when it's resolved, it may fetch it from the backend, or it may fetch it from the indexed DB. And also, this takes into consideration the language. So if this book has multiple languages and the browser is in Hungarian or so, then it would show that one if applicable. So it hides away lots of complexity. Thank you. Another example, of course, we also have lists. And this just gives us a list of books or videos, and then you use those Fluent interfaces. And so this is 2 times a Fluent interface. The query builder is a Fluent interface, but what it returns are, again, Fluent interfaces. So what are the core components of Fluent interfaces? Well, this is the core example. So basically, you just have to return this. You create an object, and this object can have state, and your methods can manipulate that state. And if you just return this, then you can do things like new thing.method A, .method B. So this is the core principle. Then one thing that is nice to be able to use are getter methods. Getter methods are defined in the following way. You add this get before it, and you are not able to give arguments, but from that moment on, you can have things like this. So that's really nice. And then one important part is that if you want to do asynchronous stuff, you need to implement something that's like a dennable or promisable. So we have this resolve callback. And when we await the item or when we call .then, it will be executed. So that's a little part of it. And await and .then are basically the same things. So that's also good to know. So here's a small example. If you can imagine a calculator, and it could look a bit like this. We have an array of commands, and we have a method where you add something. And instead of executing directly, we just push this anonymous function in the array of commands. And so you can imagine just like the add function, the minus function, etc. A bit boring. But I thought this was, I wanted to have an asynchronous example. So I added temperature for city. And here we need to do asynchronous stuff. We get the latitude and the longitude by the city name. And then we get the temperature. So here we push this anonymous function again in the array of commands. And then at the end, we start with 0. And for each command that was pushed these anonymous functions, we execute them and we override the current result. And we put the current result in the function. And this way we can do asynchronous stuff in a Fluent interface. And that looks a little bit like this. I'm not sure what it would give, what the temperature would give. But you can do things like this. So you can just do fetches, and it feels very easy to write. So another concept that's very important is the promise chain. And why that is important is that these queues are quite handy, but they're more for one-off interfaces. If you want to do something in the template layer, I'll get to that later also. But then a promise chain is much easier, and probably you all know promise chain that you can continue with it. And then we get to the proxies, and here it can get very interesting. And so a proxy is a layer on top of an object which can intercept and redefine fundamental operations on that object. And why would you want to use this? Well, it would be nice to create a Fluent interface where you have some properties that you do not know beforehand. So like this LD Flex example where I just wrote my website, and where I had my like the image that was fetched. if you do that on a normal object, it would crash. It wouldn't be possible. And so the only way that I know to do that is with a proxy in JavaScript. So this is just a basic example how it works. It's not a very good example, but it communicates what I wanted to demonstrate. So we create an object, hello world. We wrap a proxy around it. And for the get function, whenever that is called, we just return Vienna. And so in the bottom, you see that we can call hello and it will give Vienna, but also Guten Tag, which was not defined. And so that is within Fluent Interfaces, that particular functionality we are using. So those were all the small components that we can use to create a chain. Now we'll zoom a little bit back and view what kind of types are there. And I made these names up, so I just thought to categorize things. So we have a builder chain, and this is often used for making queries or filling entities. You have a class with state. You manipulate that state and you call a couple of parts, and then something is built what you can use in another component. Then you have an asynchronous queue chain, and this is very similar to the calculator that we went through. You have an object, and from each method, this object is returned. And at the end, all the asynchronous methods are executed. And here we have an asynchronous proxy promise chain. And so what is different here is that instead of returning this object with state, you will return a proxy each time. And this proxy, when it's called, you can intercept this new key. And it gets a bit complicated, but it gives you possibilities like this. You don't have to use the parentheses to catch a variable if you like it. It's a bit of work to save a bit of parentheses, but sorry. So that's the async proxy promise chain. And LE flex is an example of this. So if you want to build a Fluent interface, what things can you also consider? Yeah, I touched on this lightly, but if you want to build something that goes into a template like React, or I'm using micro HTML, it's not like if you would do a queue with a command array. That might be difficult. It might be possible, but I think it's very difficult because, as you see, the author is a promise, and on that promise, another promise is made, author.name, not given. So what happens, you can, on one promise, you can do multiple thens, and they will just resolve when the promise is done. And that makes it easy to diverge, to get different paths, and to have different Fluent interfaces. So that's, I would recommend the promise chain for template libraries. And then what's really cool is TypeScript. If you use a library from a vendor and you type and everything is nicely auto-completed, that's awesome. And that's also quite doable with Fluent interfaces. And it is also doable with proxies. So it gets harder there because TypeScript doesn't understand the proxies. So what can we do? So we can use generics. And so here we have an item and it's an array of strings. That little principle we can use to instruct TypeScript, and when it encounters a proxy, we can say, well, no, it's this and this and this and these methods. And here we have just a couple of examples of generics. So what you see at the top is you have this first capital type that is the type argument, and then the arg colon type, that is the variable. And then we see 3 examples, 1, 2, 3, where we just call this function and tell TypeScript, hey, we're calling it with this type argument. You should do something with that. So auto-completion in your editor would follow that. But in the end, we do just the argument, and that's how TypeScript also works. It just resolves whatever you give into it when it knows what it is. So here again, this is basically a stupid function because it wraps whatever you give it with a new promise and then resolves that thing. But the good thing is it let TypeScript know how to deal with it. So that's why I wanted to illustrate. Doesn't matter what you put into this, but you always have type that works, or mostly. So this is where it gets where the things get the puzzle pieces get attached to each other. You can just say to TypeScript, well, this API object that I have, instead of what you think it is with the proxy stuff, it's something else. So we just say as unknown as something else. It's basically forcing TypeScript to accept that we're lying. So, and so in that way you can do TypeScript. It gets much more, there are much more things to it, but that might be a bit boring. So the summary is Fluent Interfaces. They're great for developer experience. The core concepts, return this from your class methods. You can use getter methods. You can use proxies for unknown properties. You can use then for asynchronous stuff. And there are basically 2 types. You have asynchronous change and synchronous change. And then you have a way of resolving asynchronous change. One is with queues and one is with promises. And then I would advise a promise chain for templating. And TypeScript can give auto-completion. So, what are you going to create? So that was it.
Oh, I have a question. Can you go to the code example from the person class where you have this then method that iterates through the commands? I was shortly offline because I tweeted and I'm not good at multitasking, so I wanted to look at this again. And basically, the only reason why it works well with async await is not because the method is called then, but it's actually an async function, right? So you could call it anything. You don't have to call it then. It's just that when you call then on this instance, then it begins to work and execute all the commands that you change, right?
I think you're right, with that small exception that the await is very tied into using then. So you could also say finish, do the same thing, and then it would work. But if you call it then you can do await.
Yeah.
And it's more
conventional.
Yeah, it's like the interfaces know this, how to work with it. But yes, you're right, I think. I haven't tested it.
And unless you haven't called then basically none of these commands is executed and awaited. So you can write the longest Fluent interface that you like with all these async operations, the extra scenes, but as long as you don't call the .then on this, it actually won't execute it, just wait. That's nice, yes.
Yes.
Yeah.
And so the same thing happens if you do a promise chain, but then somewhat they are executed more on the fly and you attach whatever you want. It's a bit more complicated. That is why I didn't dive into the code example of the promise chain, because the hard thing is you have then sometimes things happening that are synchronous, and it's very hard to reason about when does it happen, where in the code flow am I. So this is the queue, something you can use for one-off things.
Very nice. I have another question with this proxy and asynchronicity. So basically, when you wrap everything into a promise, and then also have like a proxy object on top of this, have you ever profiled the performance on how much this adds instead of having like actually doing the pure async await, non-proxied way?
Yeah, so basically you have an interceptor, you double the methods, so it's a bit slower. What is interesting that I first built my library with asynchronous or with proxies. So I had a Fluent interface that worked with proxies, and then we found out that we wanted to support all the phones that didn't have proxies. And so I had to redo my whole thing. And I did wanted to have keys that I did not know beforehand. So what I created was a bit more with schemas. So my new structure is a bit different. Whenever a chunk is added, that thing is resolved. And then the new chunk is generated with the schema that is found. And that way I can have objects that have keys that you do not know beforehand. So back to your question, we found out that the performance is equally almost. And so this whole thing with the schemas and making the chunks is very convoluted. So I think proxies are not very performant. But yeah, I think in the end it's all fine. It's all okay-ish. Yeah, I don't know. I wouldn't say it's seconds. It's milliseconds. It's very fast. So. Yeah. So what happens in our templating layer when it really gets when your question is relevant for us, for example, if you have a whole template layer that renders the ebook and the author and some stuff around it, everything that we get from the backend is the asynchronous chain, and so then it adds up. So yeah, that's a good consideration.
More questions?
I have one question, since you always mention return this. What's your approach to create more restricted interfaces? If you have a interface where, say, like person dot name, but you don't want to allow them, the user to call .name again, because that's nonsensical, right?
Yeah, very good question. So basically the .this is the start of it. It helps you grab the concept, but grasp the concept. But no, you're right. So what happens most of the time is that so you can imagine an API that have projects and authors. So first you get the project and you get an object back that has these methods from the project. And then you say .author, and then you get an object back that's the author. So you're right, it's not always this.
Yeah.
But
you construct a new object with different methods.
Yeah.
That's the new interface.
Yeah. So this is just a start. This is for query builders. Yeah. This is for query builders and for objects with state that you need to fill, like an entity or things like that. Yeah.
Thank you.
So I have one or two questions. One would be, sounds like on the library author side, which is I guess your case, the whole thing would be in one file, which would be ginormous probably, if you have a lot of.
You mean the library code itself, the bundle?
Yeah.
So our library is not super big. We have a bit of code to support this offline functionality and online, and we have some multilingual code.
The whole thing is in one class, right?
No, a lot of separate classes, but compiled, it's not super big. Yeah, I don't have the stats in my head, but it's.
I was just thinking that probably naively, the more methods you add, because everything is on this, then I guess it would be hard to maintain.
Also, of course, but you can compose things. So you can, instead of, so we have this, like the commands, you can bind them again to the class, or there are ways to make it composable. Yeah.
And the other one would be, well, the way I see it, and I've used similar things like this. Also, some database ORMs are like this, then it really makes sense. But yeah, for query builders. So this sounds like it's the antithesis of functional programming, because you just mutate yourself again and again and again, right?
Yeah, well, it has some relation to functional programming. But if you want to do this with functional programming, you would have a lot of things in a lot of closures. I don't know what the exact relation is to it, but it's different, yes.
But regardless, from your side, that you have created a library and you have put it out there for other people to use, what would be, have there been any concerns from others who have used this? The way that I see it now, it looks very, like you said it well, but I cannot, I'm asking what you have taken as negative feedback, like this is what I don't like with, from the user perspective.
Sure. So a bit background about our CMS. It started to getting adopted, so we're not there yet. I'm a year and a half into this. We have a small team. I work for a charity, so things go very slow. So we have not got a lot of feedback on how to use it. We have created front-end apps with this and that are in production. I think it, like one of the spear points, it abstracts away stuff that you don't want to do each time. So checking if the browser is online or offline, and then getting the data, putting it in the IndexedDB. If you have to import a service each time you have a page to do that concept, that could get cumbersome. So yeah, I think it abstracts away nicely. But like this first question, like what is the performance? That is a good one. I have had a lot of memory leakage before it was sort of stable. So that was a very interesting problem, because exactly what you touched on, if the whole template exists of all the promises that are a chain and do a lot of magic things, then it just gets a bit slow. And what I had was that it got slow because I had memory leaks. So I had to learn a bit about memory. I had to learn how to debug it. And now that I fixed that, now it's stable. So when you have, so when I created these schemas, then there's a lot of stuff happening. And so that needs to be very memory performant. So I would say that if you create this library Fluent Interface, debugging it and knowing principles about memory, that's good. I had to learn it the hard way afterwards. Like one of the things that you have the Chrome debugger, and it just tells you how many events there are attached, because it also uses events. For me, just a simple ebook page rendered to 35,000 events. So then I knew, oh, something is wrong. So what happened was some recursive things. And so, yeah, I didn't did this project that I thought I want to do Fluent Interfaces. I just dived, I don't know. I dove into the project and thought, oh, I'm going to fix this. And so then sometimes it's a bit trial and error. So yeah.
I have a question. We use actually Fluent Interfaces in our frontend, and I was wondering, how are you dealing with like debugging? Because it's very hard. Like if you put a debugger outside of the Fluent Interface, it's pretty hard to find the correct function in there.
Yeah. So I think it's related to the composability. So it's very important that you compose the functions, that they're in separate files, and that you're what's it called? This dump of your code. If you compile,
Source map.
yeah, that you have source map, and so all these things are very valuable. I've used this Fluent interface in Dino, and so I attached my just for testing because we mainly use it in frontend. But I used it in Dino, and then I attached the debugger. That was sometimes easy to do. I think really investing time in using the debugger. I came a bit from a place where I always use console.log and console.table, but that was it. So the debugger is really good. Yeah.
Chrome, you have the ability to, if it's a multi-line expression or actually a single statement, right? It allows you to put sub-breakpoints of the statement.
Yeah.
So that actually before you get into this method, the debugger would hit again, although it's still the same statement, right? You have this
I mean, you could also
sub-granularity.
just chuck more debugger in there, but if you have like a really long chain, it's very tedious to add all the debuggers if you really don't know
Yeah.
where it's happened.
Right.
Like, it has that problem.
So well, that could be a good argument you asked. Like, I don't know, did you write the Fluent interface or do you have to work with it?
Both. Like,
Okay.
we have a Fluent interface
Yeah.
as a package, but
Yeah.
it's maintained by ourselves, but I
Yeah.
don't really want to update it.
That says a lot.
Yeah.
So that could tell like, and I don't think that that necessarily has to be the case. So I would make a strong argument for making it composable. Yeah. So maybe that's the downside. Yeah, if it's hard to, if it's like one black box, then you don't want to touch it. That is, yeah. So. Yeah.
How hard it is to, after writing Fluent interface, how hard it is to test it?
Test it.
Yeah. Like writing every single combination or how?
So when I explained about this offline and online,
Yeah.
it's a subcomponent. So this subcomponent you are able to test, and then you bind it to one of the methods. So I would say it's possible, but you have to think about, make little blocks instead of one big function. Yeah. So this Fluent Snake that I talked about, you can check out the code base, but that's one big function and it's painful. So yeah, I don't. That would be my answer.
Very good. No more questions? Then thank you, Daniel.